For this video, I will download some sample data from the internet. So I will click on this link, I will follow this link, I will go to GitHub, and from this page I will download these 9 files. Each of these files has 500 megabytes and together they have over 4 gigabytes. I will download these files onto my computer and then I will uncompress them. Inside of them I will find these 8 CSV files. Inside of each CSV file we have data for one table, and all of these tables they belong to one database, and that is a database for fictitious company with the name Contoso. These first 2 tables have 211 million rows. Orders table has 88 million rows, so these 3 tables are big. Customer table has 2 million rows and other tables are smaller. We can also see here the size of these CSV files in gigabytes and megabytes. Together all of these tables are making one sales cube. We can see that here. Inside of this cube we have 4 dimension tables. We have store, date, product and customer. Fact data is inside of the sales table and also inside of the table's orders and order rows. On this image, not all of the columns are shown. Now I have first to make one change inside of one of these tables. So I will go to date.csv file. So I will go to it, I will open it, and inside of it I will find a column with the name year. But I will add this number 2 because I want to change that to year 2, and I will also change month to month 2. I'm doing this because Monet will not accept columns with names year and month because those are reserved words. Next, I want to show you hardware specifications of my computer. So I will click here, and here we can see that this computer has 64 gigabytes of RAM. I'm using CPU with 8 physical cores, and I'm using Zorin 18 operational system. I will now jump here to terminal, and I will paste one statement that will create order rows table. I will run this, and after 4 milliseconds our table will be created. After this I want to fill this table with data, and for that I will copy another statement. This is copy into statement. This statement will read from the CSV file and it will import data into order rows table, so then this table will have 211 million rows. So I will run this statement and then we will wait. And after only 79 seconds, all of the 211 million rows were imported into order rows table. I will now clean my screen. I will go back to this blog post and I will tell you that I will not show you how to import all of these tables. Instead of that, at the end of this blog post you have a file for download, and there we will find create table statements for all of the tables, and at the start we have copy into statement for importing our data. We just have to provide names of our tables. And I also want to tell you that for import of the sales table you will have to wait about 5 minutes, and for orders table you will have to wait about 62 seconds. All other tables are already created inside of a database and all of the data is imported. And now I will restart my computer to achieve so-called cold start. I want to see what will be performance of my queries just after database is opened and is active. So I will now restart my computer and we will be again together after that restart. Now that computer has restarted, I will run one really simple query. This query will return only one row. I will run it, but we will have to wait for the result to appear. And this is because Monet is slow at the start, so this is cold start for Monet, and we first have to send several select queries for Monet to warm up, and after that queries will become faster. so Monet can optimize itself for queries that we send to it. So we have waited 20 seconds, and if I run this query again, then it will be much faster. Now it is below 1 millisecond, and this is not the result of query caching. So for example, if I run again the same query, but now if I read 2 rows, I will again be fast. I can also read 3 rows, and we will still have this great speed. I will now run one aggregate query. So I will calculate the sum of quantity from sales table. I will run this query, and this query will not be super fast. We will have to wait a little bit. So we waited 3 seconds, but if I run it again, then it will be fast. I can now run similar query that is using a filter. So I will copy this query here. I will run it, and this will obviously return some other result, but we will get that result as fast. Now it is really hard to observe speeds in Monet when numbers change like this after each run. So from now I will focus only on the fastest times. I will now run one query that will return 1,000,000 rows. So I will copy this statement, I will paste it into terminal, and I will run it. And then we will have to wait several seconds, like 7 or 8 seconds, for this query to finish. But Monet will report only 15 milliseconds. If I were to run this other statement that will return 2,000,000 rows, again Monet would report something like 24 milliseconds. And this is because databases only report the time that was spent in creation of the result of a query that was written to RAM memory. It will not include the time needed to write the result of a query in terminal or any other client. But in Monet we have a command that will suppress writing to terminal. So I will run this command, and then again I will run that query, and we will only get the time of this query. Now I can try this other statement, and this other statement will also return just the time that was used for creation of the result, and that time was only 26 milliseconds. I will now change this command back to default because I want to see the results of my queries. So I will run this, and I will clean my screen. I will now run one group by query, and this query will group results by product key. It will sum quantity, and it will calculate average of the net price. And all of these 3 columns are from the sales table. So I will run this, and this is our result. But instead of grouping by product key, if we want to group by brands, then we have to create a join between product table and sales table. And for that, I will run this join query. So I will paste it here. I will run it, and then we will have to wait 1.2 seconds. But we can speed up this query if we create a foreign key constraint between product table and sales table. So first I will create a primary key constraint on product table, and then I will create a foreign key constraint on sales table, and this statement will last a little bit more, so we will have to wait. And it had finally finished. We had to wait almost 2 minutes for this foreign key constraint to be established, but now our join query will become faster. So I will now run it again, and it will finish in only 1 second, so it is like 15% faster. I will now clean my screen, and I want to tell you that during this query execution, Monet was able to parallelize effort over all of the CPU cores. So MonetDB is really efficient in usage of CPU cores. So if we had a processor with many more CPU cores, then the execution would be even faster. I will now run one query that will use distinct. So I will get distinct values for continent and gender from the table customer, and table customer has 2 million rows. I will run it, and this would be the result. And then I will do the same thing, but from the sales table that has 211 million rows, and this would be the result. And then I will again use select distinct, but this time I will try to count distinct rows. So I will run this query. Distinct will return distinct rows, and then we would count them. But this query will be slow in Monet because we have to count 88 million rows. So we waited almost 13 seconds. We can try the other version of this query. So instead of using distinct, we will try group by. We should get the same result, but this kind of query will not be faster than this previous kind of queries. Instead of that, it will took almost the same time, something like 12 or 13 seconds. So it is the same almost result. Next, we will take a look at usage of like operator, and we will use this like operator with underscores. So we will create our pattern using underscores. So I will run this, and this would be our result. We can run the same query, but we will add 1% sign, and because percent sign is more complex for processing, we will wait a little bit more to get the result. So now the time is almost twice longer. I will now clean my screen. Before the next example, I will first create primary key constraint on the customer table, and I will use that constraint to create a foreign key constraint between customer and sales table. I will run this statement, and then we will wait. And after 25 seconds, we now have our foreign key constraint, and now I will try to run an example that is using rollup. So we are using grouping sets, we are using a rollup command. I will run this query, and this query will not be super fast. It will last for like 10 seconds. So we will have to wait. And after 12 seconds, we have our result. But we can, instead of it, use query that is based on the unions, and this query will return the same result, but it will be much faster. So I will run it, and we would get the same result after 2 seconds. So there is still room for improvement in Monet Optimizer. I will now clear my screen. I will now create a foreign key constraint between tables date and sales. I will also copy this other statement, and I will run it, and then we will wait. So we have waited for 12 seconds. And now I will try to execute a statement that is using window function. So I will copy this statement, I will paste it. This statement is using log function, so this inner query will return quantity, but it will also return quantity from the row before. And we will get that row before with this log function, and then we will sum those two columns, and we will calculate their difference. This difference will be the value of quantity in the row which doesn't have the previous value, because their log function will return null, so the difference will be actually quantity in that row. So that is something that I'm expecting. So I will run this statement, and this statement is fast, and it is really returning the quantity in that first row which doesn't have a previous value. I will now run one other statement that is also using window function. This statement has inner query that will return quantity, but it will also return a rolling average for values that are between current row and 6 previous rows. And then we will sum the values in those columns. So we will sum quantity, and we will sum those rolling averages. So I will run this, and then we will have to wait. So this query was more complex for Monet. It needed 30 seconds to execute this query. I will now clear my screen. We will now test updates in Monet. So I will update currency code column in the sales table. So I will run this statement. And after 4 seconds, this statement has finished. And we have updated 44 million rows in just 4 seconds. So this statement was fast in Monet, so we can do fast updates inside of Monet database. We can test whether we successfully updated all of the values. So I will just get distinct values from currency code column, and we can see that all of the values are successfully updated. I will now clear my screen. I will now run one ordinary group by query. I will aggregate quantity per customer. So I will run this query, and then we will have to wait because we have 2 million customers. So we will have to wait for all of them to be listed here inside of terminal. And this query ended in 5 seconds, and we have exactly 1.8 million customers. But now I want to group this query result data set. So I want to group by these quantities, and for each quantity I want to count how many customers do I have. And this can be slow because now we are doing double grouping. So first we are grouping by the customer ID, and then we group by the quantity. So we have double grouping. So I will now test such query. I will copy this statement. I will paste it here, and I'm expecting for this inner query to be fast, just like previously, but for this outer query I'm expecting to be slow. So I will run it, and then we will wait. And this query also ended in 5 seconds, so I'm pleasantly surprised because these kind of queries are slow in Power BI database. I will now clear my screen. I will now create a foreign key constraint that will connect product table and order rows table. We will wait a little bit. And after 90 seconds, we have our foreign key constraint established. I will now test so-called stitch query. Stitch query is when we aggregate values from one fact tables and we group them, and then we do the same from some other fact table, and then we join those two data sets to get the final result. And this final result is stitched query because it is stitching together these two small data sets. And to test that, I will run this statement here. I will paste it, and this statement will calculate sum of quantity per brand, and this other subquery will do the same, and then we will join those two small data sets. So I will run this query. And this is how we can aggregate two fact tables and we can group them together. But this query is slow. It lasted 8 seconds. If I run just this one subquery, so if I just sum quantity per brand for order rows table, this query will be really fast. It will last only 1 second. So why then this query here is executing for 8 seconds? If I try something similar, if I try to do union of these two small data sets, I would get the same time. So I will run this, and again we will have to wait for 8 seconds. And this is interesting because I tried to, you can see 8 seconds, because I tried one more thing. I tried to read this data set and this data set by Python, and then I joined them with pandas. And in that case, the total time for a query was 1.2 seconds. But when we join them in Monet, everything will last for 8 seconds, and I don't know why is this so slow. I will show you how we can still speed up these stitch queries in Monet. We can run something like this. So I will copy this statement. I will paste it here. So what is special here is first we will reduce sales table to only product key column and sum of quantity. So we will make sales table smaller. We will only take columns and rows that we need, and we will do the same with order rows table, and then we will follow the same logic after. So we will just first reduce our data, and then we will calculate our result. So if we run this kind of statement, then the result will come a little bit faster, so we will have to wait only 5.5 seconds. I will now make a small edit because I have found a query that will run for only 3 seconds. So I will go to terminal, and here I will paste that query. This time again we will reduce quantity of data in sales table and order rows table by grouping data by product key. And after that we will use these two interim results to create a join with product table. So we will join product table, sales table and order rows table in this subquery. So if I now run this query, it will last only 3 seconds. So this is now our result. Let us now go back to our video. I will now clean my screen. For the next example, I will remove all of the foreign key constraints from the sales table, and I will also disable optimizer. So I will run all of these statements. I will run them, and they are all successful. I will now clean my screen. With this next statement, I will read all of the rows from the sales table, and then I will insert them again into sales table. So I will append them. So then sales table will have around 400 million rows. So I will run now this statement. MonetDB spent 3 minutes in executing this statement, and now sales table has 400 million rows. I will now clean my screen. I will again run the same statement. So I will again read all of the rows from the sales table, and I will write them into sales table. So sales table will now have 800 million rows. I will run it. And after 7 minutes, our statement finished its execution, and now sales table has 800 million rows. I will now clean my screen. For the last step, I will read all of the rows from my CSV file into sales table. Because sales table already has 800 million rows, if I add 200 million rows to it, I will reach 1 billion rows. And that is my goal. So I will now run this statement. And after 7 minutes, our statement has finished, and now we have 1 billion rows in the sales table. I will now clean my screen. And next we will test whether we really have 1 billion rows in the sales table. And we can see that we really have 1 billion rows. I will clean my screen. I will now recreate foreign key constraint between product table and sales table. And after 24 minutes, this statement succeeded. I will now clear my screen. Let us now see how much time will be needed for this query that is using join between product and sales table to run. This query finished after 2 minutes. I will now clean my screen. I will now run the same query again. I want to see whether it will become faster. And now this query ended after 50 seconds. I will run it again. And this is still surprisingly slow. I will now try one similar query, but this time we will group by color to see whether that query will be faster. So I will run now this query. And obviously Monet needs more time to warm up because I saw these queries run much faster, but currently I'm getting these times that are not superb. I will now clean my screen. We are now ready for some conclusions. First, MonetDB is usually very fast, but initially, until the database warm up, queries can be quite slow. We should always use foreign key constraint to achieve a speed boost. Some queries are faster than the other one. And during this execution of queries, Monet is not using a lot of memory. So, for example, during this last query that ran on the sales table with 1 billion rows, Monet used only 13 gigabytes, and it was the same while importing data into sales table. Then also the usage was about 13 gigabytes.